What's up? What's up? It's your man Jimmy Chan. So today we start talking about hypothesis testing, right? So with hypothesis testing, the important part is that you're going to make a statement, or you're going to be given, well, you're going to make a statement, right? Because you're going to be given evidence, and then you're going to make a statement, and you're going to make two statements. One is the null hypothesis, which is denoted as H naught subscript 0. Is a statement to be tested. The null hypothesis is a statement of no change, no effect, no difference. Okay. AKA the null hypothesis is always equal to something. And the alternative hypothesis, H sub 1, sometimes H sub A, is denoted for alternative hypothesis. This statement is a statement that we are trying to find evidence to support. Okay. So kind of like if you're at the courthouse and you have been charged with something, the null hypothesis is that you are in the wrong or you are guilty. The alternative hypothesis, which is what your lawyer is trying to do, is to find evidence to support that you're not guilty. Okay. So that'd be the alternative hypothesis. All right. So three possibilities here. One, with these statements, the parameter could equal to some value, which is your null hypothesis. If you notice, the null hypothesis all say equal. Okay? The alternative hypothesis can be not equal, can be less than, can be greater than. Now, with that being said, it depends on what you say here, if it's a two-tailed test or a one-tailed test. Okay? If it's less than, then it's going to be a left tail test. If it's going to be greater than, then it's going to be a right tail test. And you're like, what is parameter mean? What's some value mean? Value is actually a value, like a number, right? The parameter could be talking about a proportion, a mean, or a standard deviation, all right? So let's take a look at some examples here. So according to the U.S. Census Bureau, 10.5% of the registered births in the United States during 2007 were to teenage turtles. A sociologist believes that this percentage is increased since then. Okay, so increased since then. So if that's the case, my null hypothesis is going to be that the P, because we're talking about proportion or percent here, that the P is going to equal to 10.5%, so 0.105. The alternative hypothesis is that P, and this is saying has increased since then, okay? So since it's increased since then, it'll be greater than 0.105. So with that being said, this is going to be a right-tailed test, right? Okay, let's take a look at the next one. According to the National Association of Home Builders, the mean price of an existing single-family home in 2009 was this amount. A real estate broker believes that because of the recent credit crunch, the mean price has decreased. Okay, so again, now we're talking about mean price. So my null hypothesis would be that the mean is equal to 218,600, right? My alternative hypothesis would be that the mean has decreased. It's going to be less now. Okay, so this is going to be a left tail test. Okay, so let's just straighten those out a little bit. There we go. All right, so let's take a look at the third. It says, according to the CTIA, the Wireless Association, the mean monthly cell phone bill What's this amount? A researcher suspects that the mean monthly cell phone is different today So different, not increase, not decrease, but different. And we're talking about mean again, so that means my null hypothesis would be that the mean is equal to the 4767, and my alternative hypothesis would be that the mean is different. So it doesn't equal to 4767 anymore, okay? So that's how you kind of take a word problem and come up with the null and alternative hypothesis, all right? Okay, so with that being said, we also have 4 possible outcomes of a hypothesis test. If we reject the null hypothesis when the alternative hypothesis is true, meaning, so if we say that I'm not guilty, right, rejecting guilty, because I am not guilty, then that is a correct outcome, right? So if I did not go past a stop sign and I'm arrested for not stopping at a stop sign, then I get let go. Makes sense. It says do not reject the null hypothesis when the null hypothesis is true. Okay, so if I did commit the crime and I was found guilty, then it's appropriate, right? Then that would be a correct outcome. Reject the null hypothesis when the null hypothesis is true. I committed the crime, but they let me go. That is not right, right? So if I'm guilty and they let me go, then that is a type 1 error. Do not reject the null hypothesis when the alternative hypothesis is true. So this would be saying I did not commit the crime, but I was still found guilty anyways. That would be a type 2 error, okay? And then we talk about the level of significance, which is alpha, and that is going to be important. And remember that as the probability of type 1 error increases, the probability of type 2 error would decrease, and vice versa. So if type 1 error decreases, the type 2 error would increase. And if the consequences making a type 1 error are too severe, then we would just use an alpha that's smaller. The smaller alpha we do, the less, the smaller the consequences of the type 1 error would be, all right? So let's take a look at what kind of error we have here. The mean score on a particular math exam is 508. A test preparation company states that the mean score of the student who takes its course is not equal to 508. 1. If the outcome indicate that the null hypothesis should be rejected when the mean of a particular math exam is 508, what type of error is this? This is called a type 1 error. Two, if the outcome indicated that the null hypothesis should not be rejected when the mean of a particular math exam is not equal. So in other words, now I'm not rejecting it when it is equal. That would be a type 2. All right. Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.